In this video, I would like to walk you through the project line balancing exercise. So this is the homework description. And one thing you need to bear in mind is the process itself, as I posted on the other day. You have 4 different stations, starting from set up the printer over here, set up a printer, and the printer start printing the part, and after the part is finished, then you have to clean up the parts before you can put that into package. And we kind of divide it into 2 stations, meaning, okay, we have the setup and the print together, and then the second station was just purely dedicated to clean up and the packaging. Okay, and I even give you the setup, like setup will be 10 minutes, and the cleanup and the packaging, each one of them will be 5 minutes. So when you look at that, okay, you want to think about that. Always remember that when we go to the Excel file and start reading through those numbers, because in that way, just bear that in mind. It will help you a lot. Okay, let's take a look at the Excel files. So let's start with the PLA, and that's part 1 of the assignment. The parameters over here is 0.6 millimeters nozzle. The infill rate is 15%, and our speed is using 0.4 millimeter draft speed. So what you see over here is 1, 2, 3, 4. Those numbers represent different stations, and the next row will be the amount of time you need to spend for each station. So for the first station, the first stage is setup. Okay, setup is 10 minutes. The second stage is the actual print. Okay, it's 72 minutes. And then once you finish the print, you take it out. It's 5 minutes to clean up and 5 minutes to package all together. If you add all of those things together, that would be 82, not 86, 82. Okay, so the safe cycle, in a sense, okay, it is 10 plus 72, that's 82, and that's what we are looking at right over here. If you print one part, it will take you 72 minutes plus the 10 minutes setup, that would be 82 minutes. And you run it to the closest quarter, so it's 90 minutes, which means what? 1.5 hours. And after 1.5 hours, you get 1 part. Compare with that, if you're using a 3-part printing strategy, even though the first question asking you 1 part per print, if you use 3 parts printing strategy and using the same print parameters, you will see that is 204. Okay, printing 3 part would take a total amount of 208, and then adding the setup, that would be the safe cycle. That would be 218 minutes, and we run it up and to the closest quarter, so it's 240. Okay, then with that is equal to 4 hours, and then but at that point in time you get 3 parts. So think in this way: if you're using the same printer, in order to get 3 parts, you need to print 4.5 hours. Okay, so you actually save 30 minutes. That means what? That means you can produce more actually. But that's focused on the 1-part printing at this point in time. So what I'm showing over here is like starting from 8 o'clock, I set up my first print. Okay, this is for the single printer scenarios. And then second setup will come in at 9:30. And third one will be 11. And fourth one will be 12:30. And fifth one will be 2 o'clock. And the last one will be 3:30. So what does that mean? In a single day's 8 to 5, okay, that's 9 hours period, I will be able to have 6 cycles for a single printer to print 6 parts, and each part was printed in a single cycle. Okay, so you have 6 cycles, and each cycle you only have 1 part. And that's where the following number kicks in. The reason why, remember the save cycle time is 82, and then we round it up to 90, right? So when you look at this one over here, right over here, 90, that means what? That means before you the first printer finishes print, you can finish a total of 9 setup. So after 90 minutes, you are going to the second setup, but if you set up every 10 minutes, set up a printer every 10 minutes, you will finish 9 printer setup. So that is something, maybe a point of reference. This is what might be a starting point. Okay, and with that in mind, 9 printer, each one of them you can have 6 cycles. Thinking that way, 9 printers, and each one of them you can have 6 cycles. Okay, so in that case, a single day you can have 6 times 9, 6 cycles times 9 printers times 1 parts per printer. So with 9 printer, using these print parameters, you can have 54 parts a day. And have 54 parts a day, and if we are using 2 people, okay, one is for setup and the other one is for cleaning. Okay, so for the cleaning, you can finish 6 package every hours. All right, so you can, in a sense, for 8-hour period, you can have 48 per day, or 9-hour period, you can have 54 per day. So it is kind of balanced, because your total print is 54, and then your total package will be 54 as well. With that in mind, you can see your weekly production, just with a single printer, 2 people doing this, you can have 270 package, or in 240 package per week. Okay, that's when you be very conservative, only work 8 hours a day. And if we look at the what you see over here, okay, so this is 9 printers, what it looks like. So 8 o'clock, 8:10, 8:20, 8:30, every 10 minutes I set up a new printer, and every printer would take 90 minutes to print. So at 9:30, the first printer is already finished the print, so I do remove the printed part and set up that again. So this is what the morning look like, and I just stopped the listing at 10 o'clock, but I continue at 2 o'clock, because what's more critical is after the last cycle kick in at 3:30, right? So this is number 6 cycle. First printer is set it at 3:30. The last printer is set it at 4:50. So the first printer will be able to finish the print, okay, finish its print at 5 o'clock. But the second printer and the rest of the printer would just pass the print time. And because the nature of 3D printing, especially the FDM printer we are using, as you can see in the videos, it is pretty much set it and forget it, ideally. Okay. Of course, if your filament is not uniform, you can have garbage print, and the whole print just scrambled together, just like a spaghetti noodles. But right now we are doing scheduling, so we assume every situation is the ideal situation. And then when we start doing the calculation of a financial model, then we bring in the scrap, okay, which means you did not finish the print properly. And because you walk away, there's no way for you to control. Okay, so do remember, even though we say 3 o'clock, 3:30, you can start setting the number 6 cycle. But remember, the first printer will be able to finish the print probably before you leave the factory. Okay, but the rest of them will just keep printing until very late. Okay. So this is something you want to bear in mind, because that also going to impact what we're going to calculate later on. Why is that critical? Because in a sense, if you just stop over here, okay, anything beyond that hours will not be considered, okay, then you did not fully utilize the 3D printer's benefit. So this day 3D printer, they can set up and automatically stop. Okay, and you can even have a remote control using Raspberry Pi, but that's another story. Anyway, let's take a close look at what the line could look like. Okay, I was asking you using different setup to play with that, and let me show you what it looks like in my scenarios. So remember, ours is 90 minutes. Okay, this is the round. Okay, we're using that as a duration to run the whole setup. And what you see over here is for the clean and pack operator or a setup. Okay, so the time duration, you might start noticing how come our setup is 10 minutes and then clean and pack, they are also 5 minutes, because I want to do an estimation. So in reality, it probably takes shorter amount of time. But remember, I don't want to push the operator to 100%, because when they are under pressure, they would have a lot of mistake. Okay, and instead of doing that, I would rather, okay, let's set up a more laid-back schedule, but pay attention to the quality. So if I start with 24 printer for the scenarios, okay, so 90 minutes safe cycle, so I can run 9 setup total before the first printer is ready for the next print. So my maximum print amount for a single setup operator will be 54. It doesn't matter how many printer I throw in. Okay, I can print up to 54 parts a day. Okay, if I'm printing 1 parts per printer. That is just a limitation of the 3D printer. So if you want to have higher production volume, you need to print 2 parts or 3 parts. Okay, and can you print more parts? It really depends on the size of the printer, and in our case, 3 parts is the maximum we can put on the specific printer we are using over here. So if I can have 24 printer, the maximum I can print is still 54. What that means is some of the printer I can use twice, okay, but some of them I probably will not even touch it. Just set it up 1 time and the day is already gone. Okay, and if I hire a clean and pack operator over here, then that person can also finish the 54 package every day. So in a sense, if I use 24 printer, this line is balanced, but there are a lot of redundant printers, okay? And you are occupying those printers just for half a day, maybe. If your business is not that busy, then it's okay. But if you have you are taking care of multiple clients, that is probably not the best practice. Now, how about we cut it half and see what's going on? So we have 12 printers, okay? Half of the 24. Again, it's 9 setup. I can print up to 54. Similarly, okay, this is a balance, but you have an extra printer, like 3 extra printers. 3 of them you will not use, okay? And then how about night printer? Night printer is pretty much an ideal situation, okay? I can have 6 different setup every day, right? As we can show, I show you over here, 6 different setup, 6 different setup, and or 6 different cycles. I can print 54 setup, 54 print parts, and then this whole line is actually balanced, and the printer are fully utilized because you only need to use those printer for this backpack hook. And how many people we hired? We hire one setup person, and the other one is clean and pack. Those two job description in the financial model, you might see, oh, okay, we are paying them differently. Okay. Now, can we cut it down further to 6 printer? Maybe this is not as profitable when I'm printing different for a different client, so I don't want to use up all my printer. Can I do 6 printer? Okay, 9 printer is ideal. Can I do 6 printer? Okay, let's take a look. This is a very interesting part because you might see some, because this one will carry over to the ABS setup, and that's something you want to learn with a single 1-part printing first. Okay, so when you look at this one, 6 printer, 90-minute cycle, 6 setup before the first printer are ready to print again. So might not be easy to imagine that. So I use this way to describe what's going on. So this is 8 to 5, okay, 8 o'clock to 4:30, and that's a 30 minutes block. For the first 30 minutes, I can set up 3 printer. Second 30 minutes, another 3 printer. And each one of them will print for 90 minutes. So the next time I start setting up again is actually 9:30. Okay, and those things will not change. Okay, the last one is still 3:30. However, when you look carefully, okay, this 9 o'clock to 9:30, this period of time, the operator himself or herself is not doing anything. In a sense, this is his or her idle time. How many idle time like this are we looking at? We can see a total of 6. Okay, so we are looking at 30 minutes idle time and 6 of them. That's 3 hours idling. And in a sense, we are looking at 75% utilization of this person's time. Okay, and how many parts are we able to get? That would be 6 cycles. Okay, the cycle time is per day is really depends on the print time. Okay, the safe cycle time of the printer. So how many cycles you can run for per printer per day is really depends on the print cycle time. All right. So you have 6 printers, 6 cycles per printer, and 1 part per print. Then you can only get 36 parts a day. And if I hire a cleaning guy, he can process 54 or at least 48 for 8 hours. Okay, that means what? I can only provide 36 for that person to work on. So we are looking at that person only have 66.7% utilization, which is pretty low. Okay, even though we said we don't want to push them to 100%, too low, you are just wasting your resource. Okay, so you want to do about 85 to 90% or maybe 80% from time to time. Okay, that's a better utilization rate. What we are looking at right now is 75% utilization and 66% utilization, which is not ideal. So the interesting part is here. What if you ask the person who set up the printer, okay, when he or she is idle, let's help on the cleaning. Okay, so he can remember the cycle time for clean and pack is 10 minutes, right? So in a sense, okay, what's remaining over here, okay, is a single person could within 3 hours. Okay, this is where the 3 hours come in. Within 3 hours, that person can clean a total of 18 parts, but we still have another 18 parts left. Okay, so this scenario is what? Just a single operator. That person is not doing is doing both the setup and also doing the cleaning. But in this case, we can only clean up half of the print. So this setup, the 6 printer setup, is still has a bottleneck over there. Okay, whether we use 2 people setup or single person setup, 6 printer doesn't seem to be enough. And you might start seeing, okay, we need to have at least 9 printer, and which is the most ideal situation. All right, I hope this is clear enough. Okay, let's move to the ABS. ABS is more interesting, even. So when you look at this one, okay, a single part would take, with this print parameter, you have 97 minutes. And the safe setup time is 107 minutes. But when you print 3 parts, you need a total of 300 minutes because the print time is 290 minutes plus a setup. Okay, so that here is 10 minutes setup plus 290 minutes print time. Okay, so bear that in mind. So if we follow what we saw just in the PLA's case, maybe, okay, we can do 30 setup before the first printer is ready for the next print. 30 printer means what? 5-hour cycle. Okay, so in a sense, we can do twice a day. The first print, the same printer, the first, when we set it up at 8 o'clock, the next time we'll be able to touch the printer, the earliest will be 2 o'clock. 13, well, let me see. No, this will be the second cycle at 1 o'clock in the afternoon. So in a single day, this is probably what we can do. Twice a day, 3 parts per print. Okay, so 30 printers times 2, twice a day. Okay, and every printer would generate 3 parts every time. So you are looking at 180 parts. And this is the rough estimation. But in reality, would that work? Okay, 180 is like maximum. Okay, but when you look at when I post online, I encourage you to use Excel to think through this whole thing because there are some tricky parts over here. Let's take a close look. So, when I use 1 person to do the setup and use 30 printers, okay, it can print 3 parts per print, 300 minutes cycle time, okay, but when you look at this one carefully, that's 9 hours a day, and the maximum setup I can do is what? I can only create 54. Set up 54 printers, or set up 54 setups, and each setup I can have 3, and that's 162. You might wonder, okay, what happened? How come there is now 180? Instead, it's a 162. That is because it is not a 10-hour cycle. Remember, each cycle is 5 hours. Okay, if you are running a 10-hour cycle every day, then you can have 2 full print. But right now, we only have 9 hours. And that's the reason why you can only have maximum production rate is 162 instead of 180. So when you set it up, you want to really use the simple visual to help you to fully understand what's going on. Let me say that again. So when we say, okay, 2 cycles, okay, and 5-hour cycle, so I can do at most 2 cycles a day. So ideally, I can say, okay, 30 printed, each one of them will run 2 cycles, and then times 3 parts per print, then I can get 180. But that is not true because some of printer you are already get off the work, you would not be able to touch it at all. This is the reality. You can only have 162. So if I hire a single individual to take care of the setup, okay, and how about the clean and pack? Remember, clean and pack, I can produce 54 per person maximum. So 162 divided by 54, okay, that's 3 people. So I can hire 3 people to do clean and setup. But in a sense, this is a balance line, okay, but not all the printer are utilized because what I just showed you, the 10th hours, another printer, 6 printer, you will not be able to touch. Okay, so this is the ceiling. That's a starting point. That's not ideal situation. Now, how about we do a 12 printer print? Okay, still a cycle time, but now I want to lay it out in this way. Okay, each half an hour I set up 3 printers. Okay, each one of them lasts 5 hours. Okay, and then before next time I can start set up the first printer, from 10 o'clock to 1 o'clock, that's idle time. In a sense, that setup personnel is not doing anything. Similarly, from 3 o'clock to 5 o'clock, because before 3 o'clock, he already finished all the setup. So we have 2 chunks of idle time. Okay, let's take a look at the output. The output is 12 printer. Okay, and we did get to do the 2 cycles for all 12 printer, and times 3 parts per printer, then we can get 72. With a single person can produce 72 parts a day. But that single personnel, okay, has idle time. It's 30 minutes each block, all right? And I have 10 different blocks, 10 different slots over there. So in a sense, it's 300 minutes idle time. What if I just follow what we show over here? At the end, we were saying, okay, let's use that person to help clean and pack. I asked that person to do clean and pack, and in a sense, that person can do 30 parts. Okay, but I have 72 parts. It is not really a balanced setup. If I hire an operator to take care of the cleaning, that person would do 54. And what's remaining is 18 parts, and 18 parts I just asked the setup personnel to help. That would take him like 3 hours. Okay, so I have 2 hours idle. So for that person, his schedule look like this: 7 out of 9 hours is fully utilized. Okay, so it's 77.8% utilized. But if you do 7 divided by 8, that is the utilization rate, it will be much higher. But the other person will be 100% because he's trying to rush out 54 package. Okay. Now let's take a look at the 6 printer. Just cut it half again. Okay, and then we'll come back to the 9 printer. 6 printer here. Okay, I follow the same token. I can lay it out, and then I can count the amount of time. I can only produce what the output is 6 printers times 2 cycles, right? We can have 2 setups every day and 3 parts. So for a 6 printer line, I can only produce 36 parts, which is half of the 12 printers. That's reasonable. Okay, but for the person running the 6 printer, now he has 420 minutes idle time. Okay, he can help to set up and clean and pack 42 parts. But remember, that's we are considered 9 hours count. If we are doing 8 hours count, then we actually have a balance. Okay, balance setup What does that mean? Okay, if we set up a schedule in this way, the yellow, it is still when the printer is printing. Okay, for the first hours, that individual will set up 6 different printers, and then he start doing cleanup until 12 o'clock. Okay, and then he will take a 30 minutes break, and at 12:30 start cleaning up again and get ready to set up. 2 o'clock he start cleaning up again. Okay, and then at 4:30 he will do the cleanup, sweeping the floor and do the bathroom and so on. So this is an 8-hour cycle, and that person is not like 100% utilized. Okay, but you have a very balanced line because you have 6 printers able to produce 36 parts, and a single operator who can help to set up 6 printers as well as clean up all the printed parts. So in a sense, what if I have 4 operators using 4 of this same configuration? That means 1 operator plus 6 printers. And every day I can have 36 out from that configuration. Then the total production rate now becomes 36 times 4, 144 parts. And 144, this one is lower than 162. Okay, but remember how many printers we actually use. We only use 24 printers, and every printer is fully utilized. Okay, and here it is a balance. We can consume all of that. Still, 4 operators, 1 setup plus 3 cleanup. Here is 4 setup. Okay, lower production rate, but what? But it is both of them are balanced line. Okay, 30 printer versus 24 printers, but you have 6 printers in the 30 printers cases which are idles, not doing anything at the second cycle. All right, I hope this making sense to you, because if you are trying to do a higher send type of skill set and then ask him or her to do that cleanup, might not be the best option because it's more expensive. But that really depends on how you pay them. Okay, last but not least, I want to talk about the night printers. Night printer, we can use the same setup over here. But you can see the idle time over here, the single person. Okay, and how many parts we can print? Night printers, 2 cycles, 3 parts. Okay, 54. So the amount of idle time is 36. So I can only clean 36 parts. I print 54 parts. I can only clean up 36 parts. So it is a bottleneck. If we use hire one clean and pack operator, can just finish the 54 parts. That means the setup operator utilization rate is super low because it's only doing the setup, and most of the time he's idling. Okay, so it's 3 hours. 1, 2, 3, 4, 5, 6, 30 minutes, right? So it's 3 hours over an 8-hour period. So your cycle time is your utilization rate is super low. It's at 37.5. That's extremely low. So this is night printer is not really a better setup. Instead, either you use 6 printers or maybe 30 printers. Okay, so I hope this really give you the idea what's going on. Okay, thank you.